Hi everyone, this is practice formative question number 9 in chapter 3, integration. So find the indefinite integral for each of the following by substitution method or the indefinite integral formula. Now let's look at this. What is the difference between question number 9 and question number 8? So over here, the expression that we need to integrate is in the form of linear expression. So in the form of ax plus b and then raise up to the power of n. So for this one, we can integrate it. Again, we can treat it as ax plus b. Okay, copy everything and then raise up to the power 1 and then divided by n plus 1. Okay, now let's recall let's work backwards. If we were to differentiate this, we bring down the power to the front and reduce the power by 1. We get back ax plus b to the power n, and then n plus 1 will be simplified. But according to the chain rule in differentiation, after we have differentiated the outside, we have to differentiate the inside. So we will have extra of a. So we have to divide that a away. Therefore, this forms the indefinite integral formula for linear expression only. Okay, therefore, this is for part B. And then part A, how do we do the substitution? It is just like the substitution method in the chain rule. So they are quite similar. So now with this two, we have to find part 1 and part 2. So let me just separate this into 2 parts. So this is for A, this is for B. So for A part 1, we have to integrate 2 over x plus 2 to the power 5. So we let u be x plus 2. Therefore, du, differentiate u with respect of x, we get 1. Therefore, du equals to dx. So with this, we're going to substitute into the expression given. All right, so 2 over the x plus 2 we replace with u, and then power 5. Because this is written in u, so our integration must be also towards the u. So instead of dx, we have to replace with du because dx is equivalent to du. Okay, so we just integrate this. Okay, we can only integrate the negative index in the negative index form. So let's integrate this. So we copy everything with plus 1 and then divided by the new power, which is -4 plus c. And let's rewrite. Oh, this can be simplified. So we have a -1 over 2 u to the power of 4, and u is actually, okay, let's just write that first and then we replace later. So u to the power of 4 plus c. And now we can put back into our original question. So whenever we see u, we replace with x plus 2, raised up to the power of 4 plus c. Okay, and then for the second method, all right, the integral formula. So to integrate the 2, we have to bring this up, negative index first, and then we start to integrate. So to integrate, we increase the power by 1 divided by the new power and divide by the coefficient for our x. So that is 1 and plus c. This one can be simplified. So we got -1 over 2x plus 2 raised up to the power of 4 plus c. So isn't it, it's the same as the method A? So we found the answer for part 1. Next, let's move on to part 2. So for part 2, okay, we let, okay, u is 3x plus 2. And therefore, du by dx equals to 3. And don't forget, our objective is to make dx the subject. So dx will be 1 over 3 of du. And now let's put this in. Okay, 3 over 5. 3x plus 2 raised up to the power 8 dx. Now we do the substitution. Put the 3 over 5 outside. We replace with u to the power of 8. The dx also we need to change. Okay, change to 1 over 3 of du. And this coefficient can be brought out to the front. So we have 3 and 3 simplified. So left with just 1 over 5. And now we integrate the u to the power 8 with respect of u. So copy everything, plus 1 to the power and divided by the new power, and then plus c. Okay, and therefore for this one, the answer will be 1 over 45. Replace the u back to its original expression, that is 3x plus 2 raised up to the power of 9 plus c. That's it by answer for part 1 by using the method substitution. And then with the method of formula, we just write, okay, 3 over 5, 3x plus 2 raised up to the power of 8 dx. Okay, so we copy everything. Copy everything, you increase the power by 1, and you divide by the new power, as well as the coefficient for the x in our linear expression, so which is 3 here, plus c. So the 3 and the 3 here can be simplified. We just simplify the whole fraction, okay, over 5 times 9, 45. So we get the same answer as the first method. Right. Of course, through this activity, we know that by using the integral formula, it is much easier. Okay, that's it for this question.